Hello team, welcome back. Welcome to Terraform training. And today let's see a demo on the VPC and the security group in AWS. So today for the demo purpose, we will create the virtual private cloud and the security group in the AWS account using the AWS Cloud Management Console. And in the coming lecture, we will do the same thing with the help of the Terraform. So first, let's see how we can create the virtual private cloud network and the security group in the AWS account. So let's go to the browser and open your AWS Cloud Console account. So you can see here we are on the AWS account, and if we will go to the EC2 instances, we don't have any running EC2 instances. Let's go to the dashboard again and over here search for the VPC. We are getting the VPC inside the isolated cloud resources. Let's open the VPC, right? And here we are getting the VPC dashboard. We have the one VPC which have the three subnets, and we have the one route tables, one internet gateway, and one DHCP protocol options, right? We have the one security group and one network ACL. If you want to create a new VPC, you can click on this launch VPC wizard. Let's click on this, right? And over here, let's change the region. So I'm going to change the US East 1, which is North Virginia in AWS. And over here we are getting the different options for the VPC. First we are getting the VPC with the single public subnet, and here we are getting the some instructions, and here we are getting the some hint information as well, that this will be the VPC and this is the public subnet which will be connected with the internet, S3, DynamoDB, SNS, SQS, and etc. And here we are getting some information as well, like we are getting a 16 CIDR block network or a 24 subnet public subnet instance using the elastic IP and the public IP to access the internet. We are getting VPC with the public and the private subnet. Over here we can define the NAT protocols as well. We are getting the define the VPC with the public and the private subnet and the hardware VPN access. So let's click with the first one, and we are going to define the VPC with the single public subnet. Click on the select. Here we are getting the IP ranges, right? If you remember, I told you that we need to define the IP range. So by default, I am getting the IP range like 10.0.0. with the 16 CIDR block. If you want, you can update it and you can leave it as it is. I'm not going to change this, and I'm going to provide my VPC name. So we are going to provide like level up custom VPC. And here I'm getting the public subnet IPv4 CIDR ranges, which is already defined like 10.0.0.24 CIDR block. Here we are getting the choice to choose the availability zone within the no preference, and we have the six availability zone in the US East 1, 1A, 1B, 1C, 1D, and 1E, and 1F. I'm not going to choose any specific one. I'm going, if you want to add the service endpoint, you can add over here. Enable DNS host name. By default it's yes. I'm going with the yes, and I will click on the create VPC. So we are getting a message that your VPC has successfully created. You can launch instances into the subnet of your VPC. Let's click on OK. And now you can see we are getting the two VPC. One VPC is this, which is the name level up custom VPC, which is my VPC. The VPC ID is 108, and this is the default VPC EF8. Now let's do one thing. Let's go to the EC2 instances and click on create new instance. And let's try to launch a new instance by click this button. Over here I'm going to choose the Amazon Linux 2 AMI. I will select it 64-bit. Right, I'm going to create the T2 micro machine. Click on the next configuration. Over here we are getting the number of instances. Suppose I'm going to create one instance, and here we are getting the network, and you can see I'm getting only one network over here, which is the DEB8. I'm not getting my custom network over here. Why I'm not getting my custom network? Because I'm creating the machine in the region US East 2, but I have defined my custom network inside the US East 1. So once I will switch to US East 1, I need to choose the AMI again. I need to choose the machine type again. Click on next configuration, and this time you can see I'm getting the both network. I'm getting the default network as well as I'm getting the custom networks. So let's choose the custom network. Inside the subnet, you are getting the subnet which we have created. which is a public subnet. I'm not going to change anything over here. Let's click on add storage. By default, the root volume of XVDA 8 GB will be attached with your instance. This is going to be the SSD GP2 type. GP2 type means general purpose 2 type machine, which have the input output operations 100 out of 3000, right? This is the minimum 100 and maximum 3000 input output operation can be accessed in 1 second. Click on next, add tag. I'm not going to add. Click on security group configuration, right? And over here I'm going to define the security group. So by default this is the security group which I'm getting. So over here we are getting an option, create a new security group. By default a new security group is listed over here, or select a security group. So I have only one security group. Let's select it and click on review and launch. So we are getting the details which we have selected. This is the AMI, this is the instance type and the memory. We are getting the security group and click on launch. So you can see we are getting instances launching. Let's click on the instance. So this instance is launching, which is in the pending state. Let's wait until the instance will be launched. You can see the instance is running. Let's open the instance, right? And here we are getting the instance, and here we are getting the properties of the instance. And you can see inside the private IP we are getting the IP with the range 10.0.0.163, and this IP within the range which we have defined inside the VPC of the level up custom VPC, right? We have defined the 10.0.0.0 with the 16 side of block range. The IP is same, 10.0.0 with some random IP number. If we will go to the details, here we are getting the complete details, and if we will go to the networking, we are getting the VPC as well. This is launched with the custom VPC, and this is the subnet. Availability zone is the US East 1C, and this is the IP. Now let's do one thing. Let's go to the EC2 dashboard, and let's go to the security groups, and let's create a new security group by click on create security group. So I'm going to define the security group name level up -SG. I need to choose the VPC. So suppose I'm going to define the security group in the custom VPC. I'm not going to define any inbound rule over here, and by default the outbound release the all traffic, which I told you. I'm not going to define any tags as well. Let's click on the security group. Okay, the description is mandatory. Let's copy the name in the description. Right now click on the create. So you can see the security group is created. Now on the EC2 dashboard you can see we are getting the two security groups. Let's go to the create one more instance, launch instance, choose the AMI. We are going to choose the 64-bit, go with the T2 micro machine, click on configuration, choose the VPC. I'm going to choose the default VPC over here. Auto assigning public IP, we will enable the public IP so that this time we will get the public IP as well. Shutdown behavior, let's choose the terminate, click on the add storage. We are going to default 8 GB XVDA SSD GP2 type machine. Click on add tags, click on configure security groups, and over here let's select the security group. And now you can see we are getting the another security group as well, which have the name level up underscore SG. Let's choose this, review and relaunch, and you can see over here you can view all the details. Let's click on launch, and let's choose proceed without a key pair. Select this and click on launch instance. Let's wait until the instance will be launched, or let's go to the instance state is pending. Let's wait until it will be done. You can see the instance is running. Let's open the instance, go to the security, and you can see over here we are getting the default security group which we created, right? So this is the way how we can create the custom VPC and the security groups. Let's go to the EC2 instances, open the running instances, open the all instances, select all and click on the terminate. Now once all this done, what you need to do, you need to delete all the resources which you have created in the AWS account, because this is the free account and we should use the limited resource in the AWS. So team, today we have seen how we can create the network and the security group in the AWS manually using the cloud console, right? And in the coming lecture, we will see how we can do the same thing with the help of the Terraform. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training. And today we will see how we can create the AWS VPC and Net Gateway with the help of the Terraform in AWS. This lecture is going to be a bit lengthy, so please be with me. So first we'll create the code files. We will understand the code files which is required for the VPC and Net Gateway creation. And then we will execute these configuration files with the help of the Terraform. So first let's go to the code editor and let's create the code files for the VPC and Net Gateway creation. So here we are on the code editor. We will close all the files. Now, as this is a new section, so we will create a new folder inside the Terraform. And I will keep it on the name of the section, Terraform for AWS Cloud. In this folder, we will create another directory called VPC underscore net underscore EC2 instance. Now over here we can see the directory is being created, which is VPC net EC2 instances. In this directory we will create a new file and we will call it vpc.tf. In this file we will write down the code which will help us to create the VPC on the AWS. But the question is, what should be the syntax? So to get the help on the syntax, you can go to the browser. On the browser you can search for the Terraform registry. We will discuss about it already, right? Open the Terraform registry. Let's scroll down and we are getting the documentation for the AWS. Open it, go to the documentation, search for the AWS VPC. We are getting the VPC resource and we are getting the AWS VPC. Let's open this, and here we are getting the correct syntax that how we can create the AWS VPC in the Terraform. So you can copy it. I will copy the actual syntax and I will paste it on my code editor. So I will comment out this first. Let's mention the comment as well. Create AWS VPC. So what we are getting? We are getting the resource name AWS underscore VPC, and this is going to be the name of your VPC. Let me customize it and we will keep it like level up underscore VPC. Then we are getting the CIDR block range, that the IP range should be 10.0.0 with the CIDR block range 16. Then we are getting the instance tenancy default. Instance tenancy means once we are going to create the EC2 instances and that instance is going to use that particular network, if we will keep the instance tenancy default, then more than one instance can be spin up on the same hardware. If you will change the instance tenancy, then each and every instance which you are going to spin up, that will be spin on a separate hardware and which will cost you a lot, right? So we are going to keep it simple. We are going to keep the instance tenancy default. Let's do one thing. Let's copy the name of your VPC and provide the same name inside the tags. Now if you want to add some more attributes inside your VPC, you can go to the documentation again. You will scroll a bit, and here we are getting the complete argument list that we can define the CIDR block, which is already defined over here. We are getting the instance tenancy, and as I told you, the tenancy option for the instance launched into the VPC, the default is default, which make your instance shared on the host. It means on the physical hardware. Using either other options like dedicated or host cost you at least $2 per hour, which is a very huge cost. So the instance tenancy must be default. We are getting few other options: enable DNS support, enable DNS host name, enable classic link, enable classic link DNS support, assign generated IPv6 CIDR block, and the tags. So we have used the instance tenancy, CIDR block, and the tags. Let's use the other ones as well, right? So I'm going to use the another one like enable DNS support, which is true, enable DNS host name, which is true, which will create the host name and DNS of your internal instance name, right? The instance name of your AWS instance will be work as a DNS. Enable classic link. We are not going to spin up the EC2 classic, so that can be false. So by this way you can generate the AWS VPC. The name of your VPC will be label up underscore VPC, right? The same is present inside the tag. Now, once we will create the VPC, what else we need? We need the subnets. So let's go to the browser and search for the subnets. And here we are getting the, and inside the VPC, we are getting the AWS subnet. and here you will get the complete syntax of the subnets. I'm not going to explain each and everything which is mentioned over here, but I want to show you this document so that you can get the reference if you want to add some resources in your Terraform configuration file. So I'm going to add the subnet directly, and then we will understand that particular subnet. So over here I have defined the one subnet which is a public subnet. The resource will be the AWS subnet. This is going to be the name of my subnet, level up VPC hyphen public hyphen one. We'll get the VPC ID by AWS VPC, then name of my VPC, then .id. This is the CIDR block range which we are going to capture in this subnet, which is 10.0.1.0 with the 24 CIDR block. Map public IP on launch. It means once the instance will launch in this particular VPC, by default the public IP will be associated by the instance, so that we are calling it the public subnet, right, which is true. Then we are going to define the availability zone US East 2A, and then we are going to define the tags, which is the name of my subnet. In the similar way we will define two more subnets, which will be in the US East 2B and US East 2C. So you can see I have defined two more subnets, right? Level up public hyphen 2, level up public hyphen 3, right? Over here the VPC ID will be same. Side of block range you need to change because we cannot overlap the IP ranges. So here I am taking 10.0.2.0 and 10.0.3.0. This is in the US East 2B and this is in the US East 2C. So we have defined the three public subnet for my VPC. Let me mention these are the public subnets. In the similar way, we will copy this code, right, and we will paste it again, and this time we need to define the three private subnet. So keep it private, right? I will change the name. We need to change the CIDR block as well, so we have took up to 3. Let's take it 4, and this time the map public on launch will be the false. Oh, they should be false. This will be in the US East 1A. Keep it private as well. The same change we need to do inside the other two private subnets, right? So we have defined few things. We have defined the VPC, we have defined the three public subnets, we have defined the three private subnets. Now we need to define the internet gateway. So let's define the internet gateway. So I'm defining custom internet gateway. You can get the reference from the documentation. I'm directly going to code the internet gateway configuration over here. So here is the internet gateway configuration. I'm going to define the resource AWS internet gateway, then the name of your internet gateway. In my case, I'm taking it level up hyphen GW. Then we need to define the VPC ID on which particular VPC this internet gateway will be applied, and then we are defining the tags. Once the internet gateway will be defined, you need to define the routing tables as well, right? That which routing table will help the internet gateway and VPC for the connection. So we will define the routing table, and again you can get the reference of the configuration from the documentation. I'm directly going to mention the routing table configuration over here. So here I'm defining the routing table. The resource will be AWS route table. This is the name of your route table, level up hyphen public. Then we are defining the VPC ID on which VPC this route table will be applicable, and then I'm defining the route. Inside the route I'm defining the IP range 0.0.0.0 with the CIDR block 0. It means all the IPs. And what is the gateway ID? Gateway ID is AWS Internet Gateway, which is this level up hyphen GW. It means the name of my internet gateway and the ID. It means all the traffic which my instance, which is using this custom VPC, want to access, they can access that traffic with the help of this particular internet gateway. But only the routing table and the internet gateway and VPC is not enough. We need to define the routing association as well. So let's define the routing association. And again, you can get the configuration of the routing association from the documentation. I'm directly going to code over here. So you can see first association I'm defining with the name level up public hyphen 1A. Over here, I'm defining two properties, the subnet and the routing table ID. Inside the subnet ID, I'm taking AWS subnet. Then I'm taking level up VPC hyphen public hyphen 1. What is this? If you will search this, then you will find that this is the name of your public subnet. See, this is the name of my first public subnet, right? So for my first public subnet, I have defined the routing table. And which route table it is using? It is using AWS route table and the name of your route table, right? Which is level up public dot id. Similar way, we will define the route association for the other two public subnet as well, which is level up public hyphen 2 and level up public hyphen 3. So I will copy this and paste it two more times and change the value as per my convenience. So level up public hyphen 2 and level up public hyphen 3. I will change the routing association name as well. So over here we have defined few things. First we define the VPC, then we define the public subnet, the three subnet for three reasons. Then we defined the private subnet, three subnet for the three reasons. Then we have defined the internet gateway, then we have defined the routing table, and then we are defining the association of the subnet with the routing table, right? So this is the configuration file of the vpc.tf. Now let's create one more file and we will call it net.tf. Over here we will create the net gateway, so that with the help of the internet gateway and the net gateway, my instance can communicate to the internet. In the net gateway, first we need to define the external IP resource of the net gateway. So this is going to be the syntax for the external IP AWS underscore EIP. This is going to be the name of the external IP resource, level up hyphen net VPC equals to true. Once this will define, we need to define the public subnet dependency with the internet gateway. And this is going to the syntax of the net gateway association with the subnet, public subnet and the internet gateway. So I'm going to define AWS net gateway. This is going to be the name of the net gateway, level up net gateway GW. The allocation ID is the AWS EIP, then the resource ID of the AWS EIP ID. Inside the subnet we will define the AWS subnet, then we are defining the first public subnet ID, and it will depend on the AWS internet gateway, and this is the name of the internet gateway. Now we need to set up the VPC for the net gateway so that the outer machine cannot access my machine. It means the machine which are present on the internet cannot access the machine of my project, of my AWS project. Although my AWS project machine can access the internet, but the reverse traffic will not be allowed. So let's provide that. So we are defining the AWS route table. This is going to be the name of my route table, level of hyphen private. Then we are defining the VPC ID, AWS VPC, the name of your VPC.id. Then we are defining the route with the CIDR block 0.0.00. The net gateway ID, over here I'm going to define the net gateway ID, AWS net gateway, then the name of your net gateway which we have just created, right? And the tag. This is the tag. So this is the route table which we are defining so that the internet gateway cannot access my machine from the net gateway. Although my machine can access the internet, right? When I'm saying my machine, it means the machine which will use this particular VPC and which will spin up inside the AWS. And as we have defined the route table, then definitely we need to define the association as well, as we just discussed in the last configuration file. So we will define the association. So here I have defined my first route association, AWS route table association. This is going to be the association name, level private 1A, right? Then we are defining the subnet ID, and over here you can see I'm defining the private subnet ID. Earlier when we have created the association tables inside the vpc.tf, we have defined the association with the internet gateway on the public subnet, right? But over here we are defining the association with the net gateway, level up private, which is net gateway with the private subnet. I will copy this code and paste it two more times, which is hyphen 1, I can call it B, and I will call it C. This is for the private 2 and this is for the private 3. Let's save this, right? So we have created the vpc.tf and the net.tf, which will create the virtual private cloud network and the net gateway on your AWS. Also we need to define the provider.tf, so we will copy the provider.tf from our existing configuration. Here is the provider.tf file. I will copy this and simply paste it over here. So now we have all the files. We have the net.tf, we have the provider.tf, and we have the vpc.tf. Let's save this and commit this code. Once the code commit will done, we will go to the Terraform machine. So you can see we are on the Terraform machine. Let's go to the directory Terraform, put ls, and over here we have all the directories. Start with Terraform, Terraform concept, and the Terraform variables. Let's execute git pull. Git pull is done. and you can see it has created all three files: net.tf, provider.tf, and vpc.tf. Put ls, and we are getting the directory Terraform for AWS Cloud. Let's go to this directory Terraform for AWS Cloud, put ls, and here we have the another directory vpc net ec2 instance. Let's go to this directory as well, put ls, and we have all three files: net.tf, provider.tf, vpc.tf. Clear out the console, execute the Terraform init. Let's wait until the init will done. Clear out the console, and now let's execute the Terraform plan. Hit enter. Okay, so it is asking for the variables. We don't, so we need to define the variables as well. So I will go to the code editor again. Here is the variable.tf. So let's copy this variable.tf file and paste it over here. We are not going to change anything inside the variable.tf file. If you want, you can remove the private key and public key path, but let's leave it. Let's save and commit this file. Once push done, go to the git, go to the Terraform, execute the git pull again. File is downloaded, clear out the console and execute the Terraform plan again. We'll provide the secret key, hit enter button. You can see the plan is in execution, and it is saying that 18 to add. It is going to add the 18 resources. It is going to add the VPC, internet gateway, then it is going to add the 6 subnet, then it is going to add the 1 routing table and the 3 routing association. Then it is going to create the another resource, the EIP, then net gateway, then routing table for the net gateway, and the 3 association with the net gateway. So total 18 resources are going to be added once we will apply the Terraform with this configuration, right? And each and everything you are getting over here, if you want to go through this configuration, let's go through this. I will show you. So first it is going to create the EIP, which is name level up hyphen net VPC equals to true. After the EIP, it will create the internet gateway. This is the name of the internet gateway, right? Then it is going to create the routing table. Over here we are getting the CIDR block range and the other parameters which are blank, right? This is the name of the routing table, level up private. Then we are getting the another routing table, level up public. We have the CIDR block range and the tag. We have the routing table association which we have defined. Right now you can see the id and the subnet id is the unknown because the subnet is not being created. In the similar way we are getting the other resources. Let's clear out the console and execute Terraform apply. Let's wait, provide the secret key, hit enter, provide your confirmation, hit enter again, and let's wait until all the resources will be created. You can see the resource creation is in progress. So the resource creation is completed, and over here we can see all 18 resources are completed. Although it took some time, you can see the net gateway only took 1 minute 40 seconds, but all 18 resources are being created. So let's see what is being created. First it is created the EIP, then the VPC, then the subnet, then the internet gateway and the subnet, then it has defined the routing tables, right? So these are the resources it has been created, and again the routing table at the net gateway. Now let's go to the AWS account and let's see actually these resources are basically created or not. So we are on the AWS account, we will go to the VPC, and over here inside the VPC we are getting only one VPC. Let's click this, and this is the default VPC. I believe we are not getting our VPC. Why we are not getting our VPC over here? Because we are inside the North Virginia, which is US East 1, but we have created the resources in US East 2. So let's switch to the US East 2, and if you want to verify, then you can see inside the variables you have defined the US East 2. I will open the variables file, and inside the region US East 2, right? Let's go to the account again and see we are getting our VPC over here. Level up VPC. This is the ID of the VPC, which is 6DE7. If we will go to the Terraform, we will scroll a bit. See, the VPC ID is 6DE7. So these resources are basically being created over here. If we will go to the subnets, we are getting all subnets which we created. You can see if we will scroll a bit, this is the private, public, public, private, private, and public. All the resources, all the subnet which are all the subnets which we created are present over here, and here is the IP range 10.0.6, 0.3, 0.2, 0.4, and 0.5. Here we are getting the routing tables which are basically being created with these. If you will go to the routing tables, you will see these are the routing tables which we have created, the private routing table and the public routing table. If you want to see the associated routes, you can open the any you can open the you can open any routing table, right? Once you will open the routing table, over here you will get the routes, right? Let's scroll a bit, or let me make it upside, and here we are getting the routes, right? Associated subnet are these. H location we don't defined, route propagation we don't defined, and here we are getting the tags which is level up private. Here is the summary which has the three subnets. If I will go to the net gateway, then here is the net gateway which is being created, right? The IP is 0df8. If we will go to the Terraform machine, then go to the net gateway, and here is the net gateway 0df8, right? 0df8. Open the net gateway, and here we are getting the private IP of the net gateway, right? The VPC which net gateway is using, which is level up VPC, and the EIP, elastic IP of your net gateway, which is 18.220.109.114. Here we are getting the net gateway tags, which is not defined. We have not provided any tag to the net gateway. Let's go to the internet gateway. We have created one internet gateway as well. And here is my internet gateway, level up VPC, right? This is the ID of my internet gateway. If we will open it, then we are getting the internet gateway ID. And this is the VPC ID. Let's open the VPC. Here we are getting the details of the VPC, DHCP, route tables, and the networks. Here we are getting the CIDR range, which is 10.0.0.16, which we defined, the flow logs and the tags, right? So all the resources which we created, all these resources are basically present over here, right? So we have created the VPC and we have created the net gateway. And in the coming lecture, we will create the EC2 instances which will use this custom VPC and the net gateway. So thank you, team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training. And in the last lecture, we have seen how we can create the VPC, route tables, route association, and net gateway with the help of the Terraform. Today we will see how we can create the EC2 instance which will use the custom VPC which we have created in the last lecture. But before going with the lab, let's see what is the requirement to create the instance with the custom VPC. So let's start with. So we are going to discuss that how we can launch the EC2 instance using the custom VPC which we have created in the last lecture with the help of the Terraform. We will be using the custom security group and the key pair to log in the AWS machine. So whenever we are going to create the EC2 instances, we need to define the security group, and that security group will have the reference of the VPC. So first we need to create the security group as well. In the earlier lecture, we have not created any security group, and we will also create one key value pair, right? If you remember, then in last section we have seen how we can create the public and private key and how we can use the public and private key combination to execute something on the machine. Today we will generate the same key pair, and with the help of that particular key pair we will see how we can SSH the AWS machine from the local box. Security group in AWS work as a firewall, and security group is also being managed by the AWS. In the AWS machine, each instance will have the security group, which is a instance level property. It means individual instance. I'm talking about the EC2 instance we are going to create in the AWS. Each instance will have the security group. And we have already discussed that at max 5 security group can be attached with a single instance. The security group in AWS is definitely managed by the AWS, and in the security group, we will define the traffic redirection rules. We will define the inbound rules and the outbound rules. Inbound rules manage the traffic which is coming to the VM or coming to the instance. Outgoing traffic manage the traffic which is coming from the instance to the outer world. To SSH the machine, SSH inbound rule must be defined in the security group. So whenever we are going to access the machine from the local box or the machine on which we are executing the Terraform, then that SSH inbound rule must be defined in the security group. So for the SSH inbound rule, we will define the ingress on port 22 with the IP range 0.0.0.0 setter block 0. It means all users will be access my AWS machine on port 22. It means all of the users which have any IP, right? If they have the internet access and they can have the IP of my AWS machine, then they can access my AWS machine on port 22. It means they can create the SSH connection, which is definitely not a good practice. So in ideal scenarios in the production machine, whenever we are going to define the ingress rules, inbound rules, we need to make sure that we are opening the port 22 for the SSH connection, but we are not opening the port 22 for the all users for the all IP ranges. We will define some definite IP range, which is the IP range of all of the machines in my organization, in my office, or in my home. So as I told you, the best practice is to only specify the IPs. We are not going to define the 0.0.0.0 slash 0 in the production machines. Definitely, we must have the IP range that which IP range my machines are using. If you remember, then in the last lecture, we have defined the IP range with the private subnet. So you need to make sure that what is the IP range of your machines, right? And these IP range must be defined inside the inbound traffic so that only these machines can access the instance which is spinned up in your AWS. We will also create the key value pair and upload the public key on the AWS so that we can SSH the AWS instance from my local box or from the machine where we are executing the Terraform. If you remember in the last section, we have done this kind of work. We have created the public key and the private key. And with the help of the public key and private key, we have created the local exec and local connection. And we have installed the Nginx and executed the Nginx on the AWS instance. Private key always be need to present on your box, which is going to SSH the AWS connection. So these are the requirements which we will follow to create the instance and use the custom VPC which we have created in the earlier lecture. Thank you team. See you in the next lecture, and in the next lecture we will see a lab on this. Hello team, welcome back. Welcome to Terraform training. And today we will see a lab on the last lecture, that how we can spin up the EC2 instance which will use the custom VPC which we have created in the last lab, right? So let's go to the code editor and let's see the configuration file which we need to create. So here we are on the code editor file, and in the last lab we have created the net.tf, provider.tf, variable.tf, and the vpc.tf. Let's create one more file over here which will called securitygroup.tf. We have created the one more file over here called security underscore group.tf, and in this file we will create the configuration of the security group which will use the VPC which we have created in this particular file, right? vpc.tf. So I'm going to mention the code directly, but if you want the reference, you can go to the Terraform registry website, you can go to the AWS resource documentation, and you can learn about it. So let's define comment security group for the level up VPC. So team, here we have created the security group. So we have created the resource AWS security group, then the name of my security group. The name is going to be allow level up SSH. Then I'm taking the VPC ID. I'm defining aws.vpc, then level up vpc.id. Here inside the VPC, you can see the name of your VPC network, level up VPC. We are getting the same over here so that this security group will refer the VPC which we have created. Then defining the name of the security group, allow level up SSH, some description over here. Then I'm defining two rules, one for the egress and another one for the ingress. Egress rule is for the outbound traffic and ingress rule is for the inbound traffic. Then we are defining the tags. Inside the tag, I'm defining the name. Let's discuss about the egress and ingress. First, we will go to the egress. In the egress, we have the property from port, from which port the traffic will be accepted, to which port the traffic will be accepted, which protocol can be used, and to which IP the traffic will be accepted. It means the outgoing traffic will be allowed to the all IPs, which is the best practice. Always allow the traffic to all IPs from your machine. Protocol minus one means all protocol. If you want, you can define the list of the protocols over here. But if you don't want to define the list of the protocols, you can define the minus one over here. Minus one in AWS means all the protocol which is applicable in the AWS. From port 0 means all port, to port 0 means all port, from port 0 means all port, right? Then now let's discuss about the inbound rules. Inside the inbound rule, I'm accepting the traffic from port double two to port double two. The protocol will be accepted on the TCP, and in the CIDR block, I'm accepting the CIDR block of all IPs. If you want, you can mention the comma separated list of the IPs from which IPs you want to accept the traffic. I'm accepting the traffic from all of the IPs, but definitely this is not a good practice. The ingress traffic should always limited. This should not be unlimited, right? We are defining over here, this should be limited. So you can do one thing, you can define the IP of your local machine or the box on which you are executing the Terraform, so that the traffic will be only accepted by these machines, right? Now we have created the security group. We need to create the create instance.tf as well. So if you will see, we have created the create instance.tf in the demo source, right? What I'm going to do, I will copy this and we will modify it accordingly. So I'm going to copy this and I will paste it over here. You can see the create instance.tf is being pasted over here. Let's modify this file as per my need. So first I'm defining the AWS key pairs. The name of the key will be level up underscore key. Let's leave it as it is. The key name will be level up key. I'm taking the public path, which is file variable path to public key. It means we have defined something inside the variable.tf file. Let's go to the variable.tf, and you can see I'm defining the path to public key, which is the level up underscore key dot pub. Then we are defining the AWS instance. I'm defining the instance name will be my first instance. AMI, I'm going to look up the AMI from the AMI's variable AMI reason. If you will go to the variables again, then over here for the US East 2, this is the AMI which we have defined, right? You can see the variable is AMI's, and we have already discussed about the lookup and other things. So we don't need to discuss all these things again and again. Instance type is going to be T2 micro, and key name is going to be the AWS key pair level up underscore key, which will be a private key, the key name. Then we are defining the tags. Inside the provisioner, we are defining something. We don't need the provisioner right here, so I will remove it. And we don't need this provisioner as well, so I will remove it. And we don't need the connection as well, because we are not going to install anything remotely. So I have removed the all unnecessary things from here. Let's add the necessary thing which we want. So what we want the security group, right? So let's add the security group first. So I'm define the security group like VPC underscore security underscore groups underscore IDs, right? And this is going to be accept the list. And inside the security group, we need to define the security group which we have created, which is this security group.tf. So I will open it, copy the AWS security group, define it over here, dot. Then we need to mention the security group name, which is allow level up.ssh. Mention it over here, dot id. One thing we also need to mention, and what is that? That is the subnet. So we need to define the public subnet of my VPC. Whenever we was creating the EC2 instance, if you remember, we have to define the subnet, then it that in which subnet we need to create the instance. So we need to define the subnet as well, otherwise it will take the default subnet. So we will define the subnet like subnet underscore id equals to, then go to the vpc.tf, and over here you can see this is my first subnet, which is a public subnet. So I will copy the AWS underscore subnet, go to my file create instance.tf and provide it over here. Then I need to define the name of my subnet, that in which subnet I want to spin up my instance. So let's go to the vpc.tf again, and let's suppose we are going to use the subnet 2 level up vpc public hyphen 2. Go to the create instance, paste it here, then provide the id. So these are the changes which we have done. We have provided the key path, we have provided the VPC security group, and we have provided the subnet ID. Let's save these things, right? And rest of the things we are present inside the variable. You can see we have the instance name, which is not required. If you want, you can remove it. We have the private key, which is also not required. If you want, you can remove it. And we have the public key path. AMIs are also mentioned over here. This variable is not in use. If you want, you can remove it. The default reason is US East 2, secret we will provide, and the access key we have already defined. Let's save this and commit this code. So you can see we are on the Terraform machine. We will go to the directory Terraform, then Terraform for AWS client, then VPC, net EC2 instances. This is the directory where we are basically writing my code. Let's execute git pull. You can see we are getting the two new files, create instance.tf, security group.tf. Now what we need to do first, we need to create the public private key first over here. So we will execute the command to create the public and private key over here first. So we will define ssh hyphen keygen hyphen f, then your key name. My key name is level up underscore key. If you go to the code editor file, you can see this is your key name, level up underscore key. Hit enter. You can put enter, enter, and enter again. Put ls, and you can see the private and public keys being created over here. Level up underscore key and level up underscore key dot pub. I will clear out the console and I will execute the Terraform plan. The 18 resources are already being created in the last lab, right? The VPC, route tables, net gateway, internet gateway, and route associations are already being created. So whenever I will execute the Terraform plan again, it will show me the new resources which I have added in the file. So I will execute the Terraform plan, provide the secret key, hit enter. You can see it is checking the earlier created resources. Terraform plan is executed. Let's go to the upside, scroll. Over here first, it has checked the earlier created resources. We are getting the refreshing state and the ID of the resources which is already being created in the AWS, right? Total 18 resources are being created. VPC, EIP, 3 public subnets. Then we have the internet gateway, 3 private subnets. Then we have the net gateway, right? Then we have the private public key. Then we have the route tables, and then we have the route table associations. So these things are already being created. Now, what is going to be create next? First, it is going to create the instance. T2 micro instance, it is going to the level up key as a private key. This is the AMI which it will use, and this is the subnet. The ID is 85D01. If you will go upside and go to the public subnet 2, then see this is the ID of this subnet. Why this is getting the public 2 subnet ID? Because we have defined the same thing inside the configuration files. Then it is going, then the name of the instance, no security groups IDs are defined over here right now because it is not created. Then we are getting the public key pairs level up, and the complete public key is printed over here. The private key is level up underscore key. Then we are getting the AWS security group allow SSH. Over here we are getting the complete egress. This is the CIDR block range. These are the IPs protocols, and in the same way we are getting the ingress as well. So that the 3 resources is going to be at. Let's execute Terraform apply. Provide security key, hit enter. Provide your confirmation, hit enter, and you can see the new resource creation is in progress. So we have to wait until the resource will be created. So you can see first it is created the security group, and this is the resource ID. Then it is created the my instance. Let's go to your AWS instance. So we will on the AWS instance, please make sure you are in the correct region. We have spent up the resources in US East 2 and we are in the correct region. We will go to the EC2 instances, and here I am getting the complete picture. You can see I have the one instance group, one key pairs, one 3 security group, and one running instance. Let's open the instance, and if you will scroll, then this is the public IP of your instance 3.15.222.198. Let's open the instance, and the private IP is 10.0.2.41. If you will go to your configuration file, go to the create instance, the subnet we have used level up public hyphen 2. Let's go to the VPC, and here is the subnet. And what is the IP range? IP range is 10.0.2.0 with the CIDR block 24. So you can see it is getting the same IP range over here. See 10.0.2. This IP will vary as per the CIDR block. This is the private DNS created. This is the public DNS created. It is creating the public and private DNS because we have defined that configuration inside the VPC. See inside the VPC we are defining the enable DNS support and the DNS support hostname equals to true. Then let's go to the security. Here this is the security group which is associated with this particular instance, and this is my custom security group. See allow level up SSH. This is the security group which I have created, and over here I'm getting the inbound rules, and inbound rule is saying on port 20 protocol TCP 0.0.0 with a CIDR block 0. The same I have defined in the security group. See port 22 protocol TCP 0.0.0, and this is the tag allow level up SSH. See allow level up SSH security group. This is the same setting for the egress as well. I'm getting port range all, protocol all, destination this, security group this. Egress 0, 0, -1, right? All protocols, all ports. So it means the resource are basically created as per the configuration we have defined. Now let's see if we will able to SSH this machine, right? Because we have defined the inbound rule for the SSH TCP protocol on port 22. So we should be able to SSH this machine. So let's copy the public IP, go to the terminal, and I will clear out the console and I will execute a command SSH. Then I will paste my public IP, then define -L for the user, and I'm going to log in with the Ubuntu user. Then I will provide -I and provide my private key. My private key is level up underscore key. Hit enter. You can see it is asking for the connection fingerprint. I will put yes and see we are on the machine, right? 10.0.241. This is the IP of my AWS machine. So we are able to SSH my machine on the AWS. Let's clear out the console. And right now I have logged in as a Ubuntu user. If you want to go to the root user, let's execute sudo -s. So you are present at the root. Earlier we have discussed that this is using the custom VPC, and that custom VPC is using the internet gateway and the net gateway, and this machine have the egress rule to access anything. It means the internet should be available on this machine. So let's execute some command like sudo apt-get update, and you can see it is updating the package manager. So if internet is not allowed on this machine, then you will not be able to execute these commands. Let's install something. Apt-get install wget and install curl as well. So you can see the curl is installed. Clear out the console and let's execute a command curl https www.google.com. Hit enter and see we are getting the complete page HTML. It means internet is accessible from this machine. If you clear out this console and execute something like www.facebook.com, then we are able to curl the facebook.com as well. So the both things are working fine. I am able to access my AWS machine from my local box, which means that ingress traffic is allowed, and I'm able to access the internet from my AWS machine, which means the egress traffic is also allowed with the help of the internet gateway and the net gateway, right? So team, this is the way how we can use the Terraform to create the VPC, security group, routing tables, net gateway, internet gateway, and how we can create the instance which will use these things, right? So here is the complete code files. I have attached these code files with the lectures. You can also get these code files from the source code location of the Git, which I have shared in the very starting of this course. So team, before closing this lecture, let's execute a command exit. Exit will close the connection. Let's clear out the console, right? And execute the Terraform destroy. Why I'm executing the Terraform destroy? Because I have created a lot of resources on my free account and I need to clean up these resources. So this will clean up all the VPC, all the routing tables, gateway, net, EC2 instance, security group, everything which we have created in the last lab and in this lab, right? Let's execute this. Once it will ask, provide your confirmation. So you can see it is listing out all the resources which is being created and total 21 resources to be destroyed. I will provide the confirmation and it will destroy all the resources. So thank you team, this is the lab, right? If you have any doubt you can ask me. Thank you team, see you in the next lecture. Hello team, welcome back. Welcome to Terraform training, and today we are going to discuss about the AWS EBS. EBS stands for the Elastic Block Storage. So let's start with and let's see what is the use of the EBS in AWS and how we can work with the EBS. So EBS is stands for the Elastic Block Storage. As the name have the storage, so it means this is going to be kind of disk. Yes, EBS is a volume on the AWS which is durable block level storage device that you can attach to your instance. So EBS is a volume type which you also can a secondary disk which you can allow and which you can attach with your running instances in the AWS. EBS is like a secondary disk with the instance which is flexible. So whenever we will create the instance in AWS, we will get few disk type attached with the AWS, and mostly that disk is the boot disk. Boot disk is a ephemeral disk, and whenever you will reboot the instance or you will destroy the instance, that disk is destroyed with that particular instance, right? Although in the AWS we can make sure that if we are going to reboot the instance, that it will not erase the boot disk, but that is against the pattern, right? That is not a recommended practice. So generally boot disk always erase. Whenever you will reboot your instance, you will destroy your instance. What if we want to save the data, if we want some kind of external disk with my computer machine? Because virtual machine is not your physical computer. Virtual machine is something which will create and destroy. But what if you want to save your data which is being created during that particular operation on the virtual machine? For this we need the secondary disk, right? The disk which will not format, which will not erase whenever I will terminate the instance or whenever I will reboot the instance. So that is the benefit of the secondary disk, and for that purpose we have the EBS. EBS is a quite flexible as well. User can dynamically increase the size of the EBS, modify the provisioned input output per second operation capacity, and change the volume type on the live production volumes. It means suppose we have created an instance and we have attached 50 GB secondary disk with that particular instance. Somehow we need that I need to increase the size of my disk. So we can increase the size of that particular disk without stop or terminate the instance. We can also modify the disk input output capacity, because in the AWS, disk input output per second capacity depend on the size of the disk, right? And we can change the volume type as well. Suppose initially I have attached the SSD, but later on I realize that I need the disk of the HDD type. So we can dynamically change that disk type as well. And we can configure the secondary disk, or we can configure the EBS disk in a way that whenever the virtual machine, the VM instances, the EC2 instances is going to reboot, is going to terminate, the data which will persist on your EBS will not be erased. That disk will not format on the stop, reboot, or destroy of your EC2 instance. And whenever a new machine, a new EC2 instance will be spin up in the AWS, the same secondary disk will be attached with that particular instance, so that the data which is being created by the previous operation on the previous EC2 instance, that will be available for the next EC2 instance as well. This is the common practice, and if you are working in the DevOps, if you have the idea of the DevOps, that how the machines are working on the production or on the cloud, then definitely you must know about it. We can remove the secondary disk and we can attach the secondary disk with the running instance, and running instance can communicate the data which is present on the secondary disk. User can attach multiple EVS volume to a single instance. That is the benefit with the AWS. You can attach multiple EVS volume with the single instance in AWS. If you are executing AWS instance, and definitely you need both kind of disk, you need the SSD and SSD. So you can attach both kind of disk as a EVS volume with that particular instance, and you can make your application intelligent that HDD type of data will be write down in some particular partition, and SSD type data will be write down in some particular partition. Because whenever we are going to attach the volumes, then we have the flexibility to attach that particular EBS with a particular partition, right? I will show you how we can attach that, and how we can attach the particular EBS to a particular partition in the EC2 instances. EVS volume and the instance must be in the same availability zone. This is the prerequisite. If we have created the EC2 instance in US East 2B, then the EBS volume must be created in the same availability zone in US East 2B. You cannot attach the EBS volume with the cross availability zone, because you will not get the option to attach that particular EVS volume with the cross availability zone instances. There are two types of AWS EVS volume. The first one is the SSD and second one is the HDD. SSD backed volume are optimized for the transactional workload, where the volume performs a lot of small read and write operation. The performance of such volume is measured on the input output operation per second. So solid state disk or the SSD is basically optimized, and that is primarily designed for the applications which have a lot of read and write output operations, right? If you need the EVS for the database, that is a directory database or the non-SQL or SQL database, then definitely you need to go with the SSD, because database have the lot of read and write operations. The second one is the HDD, right? HDD volume bake for design for the large sequential workload, where the throughput is much more important than the performance measured by the MIBS per second. It means where the operations are mostly depend on the transactional data. Where my application is primarily designed for the transactional data, where my application is something which needs a lot of bandwidth, so I will use the STD big volume for that particular application. The SDD and the HSD again divide. First, discuss about the SSD. So SSD is divided in the general purpose SSD and the provisioned IOPS SSD. When I'm going with the SSD, the first one we have the general purpose SSD. General purpose SSD is the common disk or the common EVS volume attached with the AWS instances, right? Because that is a economical, it means the price is not so high and the performance is optimized. The second one, if we need the high input output operation per second device, then we have the option for the provisioned IOPS SSD, which is a very high performance for the important applications. In the HSD as well, we have the two kind of HSD disk. The first is the throughput optimized HDD, which is inexpensive for high use intensive workload, and second one is the cold HDD, which is cheap, used for the infrequent access. So throughput optimized HSD is required for the applications which need a lot of bandwidth, where you will need to store a lot of data and you will get that data frequently. Right. The second purpose is the cold HDD, which is cheap as compared to the throughput optimized HDD. The cold HDD can be helpful for the data warehouse, that can be helpful for the archived system, where you just need to store the data and keep the data, right? You don't need to read the data frequently, so you can use the cold HDD. Let's discuss about the all four type in details. So in SSD, the first type is the general purpose SSD, which is called GP2. GP2 is balanced for the price and performance and recommended for the most of the use cases. As the name is explaining itself, that is the general purpose SSD. And if your application don't need something which is very specific, you can go with the GP2 type EBS in the AWS. The max input output operation allowed on the GP2 is 3000 input output operation per second, and the size of the GP2 may vary from 1 gigabyte to 16 terabyte, while the maximum throughput is kept 160 megabyte per second. Right? The size which you can vary in the GP2 type is 1 gigabyte up to 16 terabyte, and the maximum throughput which you can get from the GP2 type machine is 160 megabyte per second. Here 160 megabyte per second throughput is about the bandwidth which you want from your hard disk. The second one of SSD is the provisioned IOPS SSD, which in short is called IO1. That can be used for the critical production application and database that need high performance, which will support up to 32,000 input output operation per second. If you have a very critical production application, like you have the HBase, like you have the Cassandra application, Apache HBase application, or you have some high performance database, then definitely you need to go with the SSD IO1. But that is a bit costly as compared to the GP2 type, right? IO1 type provide the 32,000 input output operation per second, which is a quite high number as compared to the GP2 type, which supports only 3000 input output operation per second. The IO1 volume size vary from 4 gigabyte to 16 terabyte, right? While throughput is maxed up to 500 megabyte per second, which is also a very high as compared to the GP2 type, which is just 160 megabyte per second. Then let's discuss about the HDD, throughput optimized HDD, which is called ST1. HDD is designed for the application that requires the larger storage, bigger throughput, such as the big data, data warehousing, where the input output operation are not that relevant as compared to the SSD. So we can go with the HDD type ST1 in that case. The maximum throughput which we can kept in the HDD ST1 is 500 Mbps, and size may vary from the 500 gigabyte to the 16 terabyte. Then we have the cold HDD, which is called SC1, and SC1 is magnetic storage formatted suitable for the scenario where the storing data at low cost and maintain criteria. Size may vary from 500 gigabyte to the 16 terabyte. Throughput can reach up to 250 megabyte per second. So these are the four types of the EBS. So team, if you are surprised that why I'm discussing the AWS so much in the Terraform, so that is necessary, because first you need to understand the basic concept so that we can easily learn the Terraform. whenever I'm going to attach the EBS with the help of the Terraform, and if you don't know about anything about the EBS, that what is the GP2 type, what is the ST1, what is the SC1, then definitely you have the questions, and these questions will waste your time. So that I'm explaining each and everything so that you don't have any questions and you can learn better. So thank you team. In the next lecture, we will see a demo on the EBS. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training, and let's see a demo on the AWS EBS. So today we are going to provision the EBS with the help of the AWS Cloud Console Management, and we will attach the EBS with the running EC2 instance, right? In the coming lecture, we will do the same thing with the help of the Terraform. So let's go to the browser and open the AWS Cloud Console Management. So we are on the AWS Management Console, and here we will go to the EC2 instance first. Let's see if there is any instance is running, and no instance is running in my project. So I will launch a new instance by the launch instance button. Click on the launch instance, select the AMI. I am going with the Amazon Linux 2 AMI HVM. I will select it for the 64-bit. I'm going to spin up the T2 micro machine. Going to the configuration, the number of instance will be 1, and here the network which I'm getting is the default. Inside the subnet, let's choose subnet in the US East 2B. If you want, you can select in any other one as well. Auto assign public IP is true. The tenancy, I'm going to choose the shared. Click on next, add storage. Inside the add storage, you can see it is attaching a volume root dev xvda, right? The snapshot name will be this, and this is a 8 GB, and this is a general purpose machine, right? The input output operation supports is 100 by 2000, 100 by 300. And over here I'm getting the encryption. No encryption, if you want you can add the encryption as well. And over here you can see this is the general purpose GP2 machine. This is the boot disk of your machine. Go to the ads. I don't want to tag any ad, or you can tag it. Suppose I'm tagging ad like custom level up instance, and the same thing I'm going to put inside the value. Go to the configuration setting. I'm not going to change anything. The SSH allowed on TCP port 22. Review and launch. Click on launch. Right inside the key value pair, I'm going with the proceed without key. Acknowledge and click on launch instance. So let's wait until the instance will be launched. I will go to the instance, and this is pending. So we have to wait until the instance will be in the running state. Instance is coming in the running state. Over here inside the menu bar, if you will scroll it down, you will get the elastic block storage EBS. Here we are getting the volumes, so I will click on the volume. Here you can see already 8 GB volume is running. That 8 GB volume is the volume which is just created with my instance, right? This is the root disk of my instance. And over here inside the description, if you will go down, then over here we are getting the attachment information. Inside the attachment information, I'm getting my instance, right? And the volume type is dev xvda. Let's create one more volume over here. And first we need to select the volume type. So we are getting the option like general purpose GP2, IO1, IU2, SC1, ST1, and the standard. I'm going with the GP2. Over here I need to select the size of my volume. So suppose I'm selecting 30 GB. On the basis of that particular size, these input output operation may vary. Now I'm going to choose the availability zone. In which zone my machine is running? My instance is running in US East 2B. So I will select the zone US East 2B. I'm not going to add any snapshot over here. If you want to tag add, you can tag it custom level up instance. Instead of instance, let's tag it EBS. Copy the same, provide in the value. Create the volume. Volume is created. Let's go to the volume ID, short it over here, and you can see the volume is available. The earlier volume, which is 8 GB, that is saying in use, but this volume is just available, that is not in use. That is the 30 GB volume which we just created. And what is the volume ID? Let's get the volume ID. Volume ID is triple V2. Over here we have selected the volume. Inside the attachment, you can see I'm not getting any attachment information, right? The input output operation, availability zone, volume ID, we are getting all these three things. Let's click on the action. Over here click on the attach volume, and here search for the instance. So here the only one instance is running and I'm getting that instance. I will select it. Now here we need to supply the device name. By default it is saying that dev SDF, but over here we are getting some hint as well, right? Either we can go with the dev xvdf or we can go with the dev xvdp. Let's go with the xvdp. Click on attach. It will take some time, let's wait. And you can see the volume attachment is done. We are getting the state in use, and that is in use with the same instance with the id 01b. Here we are getting the partition name and the status is attached. If we will go to the ec2 instances, you can see this is the instance 01b. If I will open it, I will go to the storage. Then over here you can see we are getting the two volume attached. One is the 8 GB, that is the root disk, and another is the 30 GB, which is the secondary disk which we just attached. So this is the way how we can create the EBS and attach the EBS in the AWS, right? Let's do one thing. Let's terminate this instance and let's wait until the instance termination will be done. So you can see we are getting the status shutting down the instance. The instance state is terminated. We will go to the volumes again, and over here you can see the 8 GB EVS volume which was created at a boot disk of the instance is being deleted. Only that volume exists which are created manually, and you can see the state is available, that is not in use. If you will create a new instance, you can attach the same volume with the new instance as well. That volume will not terminate, will not delete, will not format with the instance which is being going to reboot or terminate, right? Because that is like an external disk with your computer machine or a secondary disk with your VM instances. So team, this is the way how we can work with the EBS. In the coming lecture, I will show the same thing with the help of the Terraform. We will create the EBS instance with the help of the Terraform, and we will see how we can attach the instance and how we can create the data on the secondary disk in the AWS instance. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training, and today we will see a lab on Terraform, that how we can create the EBS and attach the EBS volume with the EC2 instance. So let's start with. So let's go to the code editor and let's create the configuration file for the EBS. So we are inside a code editor. I will close all the files. And now inside the Terraform for cloud section, I will create one more directory and I will call it EVS volume. Now we have a new directory EVS volume inside the Terraform for AWS cloud. Inside this directory, what I will do first, I will copy the provider.tf which have the provider information. Then I will copy the variables.tf. Variables.tf have the all variable information. Next, what I will do, I will copy the create instance.tf and I will paste it inside the ebs.volume. Right? So we have three files: provider.tf, which is for the AWS provider, variables.tf for the AWS variable, and create instance.tf. In this create instance.tf, what we have the resources AWS key pair level up. Let's leave it as we are going to need it. Then we are creating the AWS resource. My first instance is the resource name. I'm taking the AMI from the variables file. Instance type is t2.micro. Then I'm taking the key name, key value pair, which is required, so I will leave it as it is. Then I'm taking the VPC security group and subnet ID. I will remove it because I don't need the VPC security group and subnet ID over here, right? I'm going to use the default subnet. What we need to add? We need to add the resources for the EBS, and we need to attach that EBS inside my AWS instance resource. So let's attach the EBS resource configuration over here. So I will create a new resource, comment a section EBS resource creation, and over here I have defined one more resource called AWS EBS volume. The name of the EBS volume will be EBS-volume-1. This volume is going to be created inside the US East 2A. The size of the volume will be 50 GB. The type of the volume will be GP2, and this is going to be the name of the volume, which is secondary volume disk. So we have created the instance, we have created the volume. Now what else required? The attachment. Attach EBS volume with the AWS instance, right? And for the attachment, I need to add few more configuration. And here is the configuration for the attachment. I'm defining a resource AWS volume attachment. Then we need to define the name of the resource, EBS volume 1 hyphen attachment, the device type, which is dev xvdh, then the volume id. Volume id we will get from the AWS volume, then volume name dot id, then the instance id. Instance id we will get from the AWS instance, then the instance name, then dot id. So this is the configuration file which is required. Let's commit out this configuration file. So we have created three files: provider.tf, you are already aware it; variables.tf, you are looking into this file since starting of this course; and the creation instance.tf. Just this section is new for you, rest all of the configuration you are already aware, right? I will save this and commit this. Once the code commit will done, we will go to the machine where we are executing the Terraform, and we are inside the Terraform machine. Let's go to the directory Terraform. Inside the Terraform, we will execute the git pull. You can see all three files are basically being downloaded inside the directory EVS volume in Terraform for AWS Cloud. I will go to this directory. I will copy this. So cd Terraform for AWS Cloud, then EBS volume. Put ls, and you can see all three files are present over here: create instance.tf, provider.tf, and variable.tf. If you remember, we have used the public key as well. So we need to generate the public key. So I will copy my key name, generate the public key. Right? The command will be same: ssh hyphen keys and hyphen f, level up key. Hit enter, hit enter, enter, and key is generated. Put ls, clear out the console and put ls again. You can see the public key and the private key is present on your box. Now this is a new directory, so we will execute Terraform in it. Once the initialization is done, we will execute the Terraform plan. Provide the secret key, hit enter. So you can see four resources are going to be created. What are the four resources? Let's see. So the first resource is the EVS volume. The size is 50 GB. The type is GP2 and this is the name. The second is your instance. Your instance is going to choose this AMI. Type will be T2 micro. Then it is going to be create the public key and the private key. Then it is going to create the attachment, right? The device name and the volume ID. These other things are mentioned over here. Clear out the console and execute the Terraform apply. Provide your confirmation and let's wait until all the resources will be created. Now you can see all four resources are basically being created. We will clear out the console and go to the AWS, go to the EC2 instance. You can see here we are getting one running resource. Let's go to this resource, and you can see the resource is created in US East 2A, right? If we will go to the volumes, then two volume is present over here. One is 8 GB, which is the root volume, and this is the 50 GB, and name is secondary volume disk. It means this is the volume which is being created by the Terraform. Here it is showing that this is attached to this instance. If I will open the instance, then here we are getting the complete details of the instance. Inside the tags, we are getting the name custom instance, which is being created by the Terraform. So we have created the instance, and this is the public IP of the instance. I will copy the public IP, and in the instance, if we go to the details, then we will move to the EBS section. Then we are getting the root device and the block devices. Right inside the block disk, we are getting dev xvdh. This is the disk which we created, which is 50 GB disk. See, this is the volume which is attached. The delete termination is false. And over here we are getting the key pair as well, which is level up key. Now what I will do, I will copy the public IP of this instance. Go to the terminal, I will type SSH, then the public IP, then hyphen L, then the username, Ubuntu, then hyphen I, and then the key name, which is level up underscore key. Hit enter, provide your confirmation, yes. So you can see you have logged in inside your instance 172.310.122. See, this is the private IP of your machine 172.3.1.0.122. Let's switch to the root, sudo -s, and over here let's see how many disks are attached. So if we will create df-h, then we can see we have few disks. This is the 8 GB disk, which is xvda1. See, 7.7 GB is basically in size. Why I am getting 7.7 GB on the box although the 8 GB is attached? Because AWS will consume some disks, so that we are getting only 7.7. But over here you can see we are not getting the disk which we have attached with this instance. If you will go back to the details, we have attached the dev xvdh, and that is not defined over here. We are not getting that disk which is in 50 GB size. Why we are not getting that disk? Because initially AWS will attach a bare metal machine, a bare metal disk with the instance. Until unless you will create the file system on your disk and mount that disk inside your instance, that disk will not be reflected in your instance. So what I will do, I will clear out the console, and first I need to create the file system on my disk, right? So to create the file system on the Linux disk, I will create mkfs.ext4. This is the file system type on the Linux. Then I need to define my disk name, which is .dev slash, let's copy this, dev slash xvdh. I will copy this and provide over here. So you can see over here we are getting allocating group table done, writing table done, creating journal of this particular block size is done, and this is done. But if you will put df-h, my disk is still not present. I'm not getting the 50 GB disk over here. What I need to do next? I need to mount that disk to this particular instance. So I will execute a command mkdir -p slash data. Then I will execute mount dev xvdh, which is my disk path with the data directory. So this is the thing which I told you, that you can mount a specific EVS volume to a specific block or a specific partition on your box. So over here I'm mounting the dev xvdh, which is a 50 GB disk with the partition slash data. df-h, put again, and see we are getting the 50 GB disk over here on the slash data partition. Now, although we have mounted the disk, but what happened whenever you will reboot this machine on which I am logged in, this particular disk will again gone. So how we can save that? How we can save the external disk to gone whenever I will reboot this machine? For this, you need to enter this particular disk entry inside the FS tab, right? So let's clear out the console and reboot the instance. So let's clear out the console and execute df-h again. You can see the data disk is over here, which is 50 GB. Now let's do one thing. Let's reboot this instance and see if the data disk is again deleted or not. So I will go to the instance, select the instance, go to the action, go to the instance state and click on reboot. Click reboot yes. I will refresh this so that I will get the correct instance state. It is still in the running. And you can see once I will reboot the instance, the connection is gone, right? Let's try to connect the machine again. I'm still not able to connect my machine. We have to wait until the machine will reboot. Machine reboot is done and I'm inside my machine. Let's execute df-h again. See, as soon as I have done the reboot, that particular disk is gone. Now, what we can do in that case, so that whenever the reboot will done, the disk will not lost. How we can achieve that thing? So let's clear out the console, put ls and create the data directory again. So I will execute mkdir -p slash data mount dev xvdh slash data. Oh, I need to switch to the root. Sudo -s, clear out the console, create the directory and mount the directory again. df-h, and directory is mounted again. Now, how we can secure that on reboot this data disk will not be removed? For this, let's open the FS tab. Right, inside the FS tab we have only one entry. Let's keep one more entry over here. And what that entry? That entry will be dev xvdh, which is your directory. I want to mount it to the data. The extension type will be etc4 and define the defaults 0 and 0. Let's save this file and now let's reboot your instance. So I will go to the AWS again, select the instance, go to the action, instance and reboot. Yes, reboot. Go to the terminal, connection is lost. It means the reboot is in progress. We have to wait until the reboot will done and we will log in the machine again. Let's try to connect the instance again. Instance is connected, switch to the root, sudo -s and execute df-h again. And you can see my disk is not gone. My disk is here, right? So this is the way how we can secure the disk on the reboot. Go to the data, put ls, there is nothing. But if we will create some data over here, and I will terminate this instance and attach that particular disk or this disk with some other instance, in that case the data will still gone. So let's create some data over here like mkdir. Go to the test, and here let's create some file echo. Hi, this is Anshul. Write this data to some file like test.txt. Put ls. The file is here. Get the content of the file. Get test.txt. We have the content over here. Now let's reboot the machine again. So we'll go to the cloud console and we will reboot the instance again. You can see the connection is gone. We have to wait. Let's try to connect the machine again. The machine is still not up. We have to wait. We have connected the machine. Let's go to the data. Put ls. And we have the test over here. Let's go to the test. Put ls. And we have the test.txt as well. Let's execute the cat. And yes, content is present. So although I have reboot my machine, but the data dictionary, the data which is present inside the EBS volume is still remain. That data is not gone. But what happen if I will terminate this instance? If I will terminate this instance, then will this data which is present inside the EBS volume that will persist or not? Let's go to the cloud console, go to the actions and click on terminate. So we are terminating the instance which is attached with the EBS volume. You can see it is showing shutting down. Let's wait until the instance will be terminated. On the box as well, it seems you have lost the connection. Let's clear out the console and execute a command terraform plan. You can see the terraform has done some check. It is saying refreshing state, EBS volume is exist. This is the ID. The level up key, refreshing state, level up key is exist. The instance refreshing key is this. And you can see Terraform was refreshing some already created resources, and this time I'm getting two resources need to be created. I'm not getting the four, only two resources need to be created. And what are those resources? The first is EVS volume attachment, and second is the instance itself, because I have terminated the instance. Let's do one thing. Let's clear out the console and execute the Terraform apply. It will create the instance. We have to provide the confirmation. You can see the resource are added. We will go to the AWS, refresh the console, and this new instance is basically created by the Terraform. I will copy the external IP of this instance, open the instance, go to the EBS mode, and you can see the same disk is attached on this instance as well. I will go to my terminal, clear out the console and try to connect to this instance. So in my command, I will change the IP because I have created a new instance. Because I have created a new instance, provide yes, and you are inside the instance, sudo -s. We are at the root, execute df-h. The disk is not here. We need to attach the disk again. mkdir-d-p/data mount/dev xvdh./data. So team, if you remember, I have not deleted that disk. The disk is already created by the Terraform, and we have created the data inside this particular disk. I just deleted the instance df-h, and the disk is attached. Let's clear out the console, go to the data, put ls. You can see the test is here. Go to the test, put ls, and you can see the text.txt is again here. So this is the way how we can preserve the data, or how we can contain the data in the external disk whenever we are terminating, relaunching, rebooting the instance in the AWS. And this is the way how we can do all these things with the help of the Terraform. So let's do one thing. Let's exit out from here. Let's exit one more time. You have exited, and execute Terraform destroy. So team, this is the way how we can work with the EBS. In the coming lectures, we will see some more interesting things about the EBS and the volumes. Thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training, and today we will discuss about the AWS user data, or we can call it user data in AWS. So we will discuss about the user data and we will see how we can pass the user data at the time of the instance launch. So let's start with. In the AWS, user have an option to pass the user data to instance at the time of the instance launch. And that user data may have the script, that may be the startup script, or that may be the configuration script, that may be related to some kind of software installation script. So whenever you want to install, you want to configure, you want to execute something just after the instance launch, you can pass that particular thing inside the user data. So suppose to execute the application, we want to set up the environment for my application. So that environment setup script can be mentioned inside the user data. And once the instance will be launched, that script will execute on that instance so that it will create the environment for your application. And later on, you can start your application without set up the environment on the AWS instance. User data can be used to perform the common automated configuration task, even run scripts after the instance starts. So the same thing I mentioned, that all the common automated configuration which you require on each and every AWS instance, or some specific configuration which is required to set up the environment for your application, that may be mentioned inside the user data and passed to the AWS EC2 instances at the time of the launch. And here is an important point, that user can pass two types of user data to Amazon EC2 instances. The first type is the shell script itself, and second is the cloud init directives. So we can pass two kind of user data to the AWS EC2 instance. The first one could be the simple shell script. You will define each and everything inside the shell script, and whenever the instance will launch, first that particular shell script will execute on the AWS instance. And second one is the cloud init directive. So we can mention the cloud initiate directive inside the AWS, and these cloud init or initiate directive will be execute first whenever the install will launch and started successfully. User data shell script must start with the hash and exclamation character. This is called shebang in the shell, right? And then the path of the interpreter that you want to read the script, commonly use bin bash. So whenever we are going to define the shell scripts inside the user data, the first line of your shell script must be hash exclamation bin bash, which will define the interpreter for the execution of that particular script. A script entered as user data are execute as a root user. So do not use the sudo command in the script. All the script which is going with the help of the user data, that will execute by a root user. So by default, the file will have the root permission on the box. It means we don't need to define the sudo command in each line of your script, or sudo command anywhere inside your script. By default, the user data script and cloud init directive run only during the first boot cycle when an EC2 instance is launched. That is an important point to discuss, right? So all the script, all the configuration we are going to define inside the user data script or the cloud init directive, that will execute only once, right? And that is the time when the instance will launch first. After that, if you will reboot your instance, you will start your instance, you will restart your instance, that script will not execute again on your AWS instance. So all the user data script execute on your instance at the time of the launch only. If user stop the instance, modify the user data and start the instance, then new user data script will not execute automatically, right? As I mentioned, that user data script or cloud init directive only execute at the instance at the time of the launch. If you are going to reboot, restart, start, anything apart from the terminate relaunch, that script will not execute on your EC2 instance. So in the coming lecture, first we will see how we can execute the shell script as a user data with the help of the Terraform on AWS instance. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training. And today we will see a lab on user data. We will see how we can execute the script after the launch of the instance with the help of the user data in Terraform. So let's go to the code editor and let's create the configuration file for the user data. So here I'm inside the code editor and we was working in this section Terraform for AWS Cloud. Here I will create one more directory and I will call it user data. Inside the user data, what I will do, I will copy few files. So inside the EVS volume, I have three files: create instance, provider.tf, and variable.tf. I will copy all three files and paste it inside the user data. Now inside the user data, we are very much aware that what is the content of the variable.tf. We are aware with the provider.tf, but we need to change something inside the create instance.tf. Inside the create instance.tf, first we have the key value pair, then we have the AWS create instance, right? Inside the AWS create instance, we have the AMI, which is common, which is coming from the variable.tf, and we have discussed about the lookup functions. We have the instance type, availability zone, and the key. Let's leave it as it is. We are not going to change anything over here. Then we have the two other resources: AWS EVS volume and AWS EVS volume attachment. We don't need these resources right now, although in the next lecture I need these, but right now I don't need these, so I'm removing these things over here. Now, as we are going to provide the script in the user data, so first we need to create the script. So I will create some script inside the user data. I will create a file and I will name it like install apache.shell. And in this install apache.sh, I will mention the code which will help us to install the Apache on the Ubuntu box. So I'm going to execute this file. First, as per the instructions, I need to define the shebang, which is bin bash. Then I'm going to update the package manager. Then I'm going to install the Apache 2 with the -y. We are avoiding the confirmation at the runtime. Then we are going to start the Apache 2 as a systemctl service. Then we are going to enable the Apache 2 as a systemctl service. Inside the file where www.html.index.html, we are going to write down this particular string. Let's modify this string a bit. Deploy machine via Terraform. Let's save this file. Now we have created the shell script, but we need to mention the same thing inside the create instance.tf as well. So after the file name, we will provide the user underscore data. This is the directive, and here we need to provide the file location. So I will call file dot, then within the double quote we will provide the file name, and my file name is this. So I will copy the file name and provide it over here. So we have defined the user data, and we are defining the user data on the basis of the file, and then I'm providing the file name inside the file. And here at the same location where the create instance, provider.tf, and the variable.tf are present, I have my file install apache.shell. Right now I will save it and I will commit this code. I will do one more thing. I will print out the output variable and I will print out the public IP of this particular instance as output variable, because sometimes we need to SSH the machine, and in that case we need to go to the AWS again and again, and we need to copy the public IP. So for the output variable, I will define the syntax like output public underscore IP AWS instance, then my instance name dot public IP. So this will print out the output variable on your console. I will save this code and commit this code on my Git. Once the commit will done, we need to go to the Terraform machine. We need to go to the Terraform and execute git pull. You can see all four files are downloaded in the location Terraform for AWS user data. I will go to this location Terraform for AWS and inside the user data. Put ls, we have all the files over here. Now clear out the console, execute the Terraform init. Hit enter. Once the init will done, execute the Terraform plan. So plan is to add two resources. One is the key value pair, and if we will go upside, the another one is the instance itself. Inside the instance configuration, if we will scroll it down, we will get the user data, and inside the user data we are getting the object ID, right? Because we are providing the user data. After this, let's execute the Terraform apply. Hit enter. Provide your confirmation. This will create the instance, and we have to wait until the instance will be created. You can see we are getting the public IP as well. Now with the help of this IP, we will log in our machine, SSH, and command is here. I just need to replace the IP. Clear out the console. We are inside the Amazon instance. Now on the instance, if you will execute a systemctl status Apache 2, because this is the service which we have started, then you can see my service is running, right? If I will go to the AWS, you can see the one instance is running. I will open this instance. Here is the public IP of the instance. I will copy this, go to the browser and hit this IP. See, we are getting our custom message deployed machine by Terraform. Please make sure if you are not able to access this IP, then you need to go to the security group attached with your instance. Here you will get the security group. I'm click on security group. I need to go to the inbound, and please make sure inside your inbound you are allowing all traffic from the IP 0.0.0.0 with the CIDR block 0, or you can allow the all traffic from the IP of your machine from which you are trying to access the AWS instance. So this is the way how we can execute the user data with the help of the script. You can see we are able to access the machine and Apache service is running, and we are getting our custom message which we have provided, right? The same custom message we have provided inside the code file. If you will go to the shell file, see deployed machine by the Terraform, deployed machine by the Terraform. Now let's go back to the terminal, exit out from the AWS machine and execute Terraform destroy. So team, this is the way how we can execute the script with the help of the user data on AWS instance. Thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training. In the last lab, we have seen how we can execute the user data with the help of the script. Today we will see how we can execute the user data with the help of the cloud init. So let's go to the code editor and let's create the configuration file for the user data using the cloud init. So over here we are inside the code editor files, and I will create one more directory inside the Terraform for AWS, and I will call it user data cloud init. I will copy the create instance, provider.instance and variable.instance in this particular directory user data cloud init because I need these files, right? So we have copied all three files. We don't need to change anything inside the provider.tf, and we don't need to change anything inside the variables.tf. What we need to change, we need to change the create instance.tf. And very first, you can see over here we are reading the user data from a file. No, we don't need this. Inside the user data with cloud init, we will read the data from the cloud init file. So what I will do, first I will create the cloud init file. So I will create a file called cloud init.tf. Inside the cloud init.tf, we will provide the cloud initialization parameters. Cloud init.tf file will be the configuration file which will use some CFG file to initiate that particular thing. So I will create one more file over here and I will call it init.cfg, right? And inside the init.cfg, we will mention the configuration which we want to execute as a user data. So if you go to the last lecture, we have created the instance apache.shell file. We need to convert this complete configuration into a init.cfg. So first we will define some comment, and over here we need to define the CFG configuration. And very first we will define the repo underscore update true and repo underscore update all. What this will do? This will update the all packages present on your box. It doesn't matter you are using the Ubuntu box or the CentOS box, right? You don't need to specify the commands like apt-get or yum update. It will automatically, Terraform will automatically manage and it will update all the packages present on your box. Now you can see inside your configuration after the package update, what we was doing, we was installing something, and what we was installing, we was installing the Apache 2. So we will define the packages over here, and over here we need to define the package which I want to install. I want to install the Apache 2. So I will define the Apache 2 over here. Now you can see after the package installation, what we was doing, we was executing some systemctl services. So we need to mention that systemctl services as well. How we can mention the systemctl service? So systemctl service is something over here we are executing some command on the box. So to execute any command in the CFG file, we will execute a directory run command, then define the same command as it is, right? We need to define the systemctl start. So we will define the systemctl start Apache 2 over here, and then we was enabling the Apache 2. So we will enable that and we will define it over here, right? And what we was doing in the next line, we were executing, and in the next line we was executing some shell command. See, this is a shell command, this is not the Linux command. The difference in the command systemctl is a Linux command, but that echo, then we are typing something inside the index.html, that is a shell command. So we need to define the shell syntax over here. So how we can define the shell syntax, let's see. So we will define an array, and over here we will define sh comma hyphen c comma, inside the double quotes you need to define your command. What is my command? My command is this. Now you can see we are getting double quote inside the command as well, and double quote we are getting inside the starting of this command as well. So how we can avoid the double quote over here? And to solve this, what you can do, you can convert the first quote as a single quote, right, and last quote as a single quote. So we are passing this particular command with the help of the cfg file. So over here we have break that particular shell script into some cfg file. First, we are updating all the packages. Then with the help of the package directory, we are installing the Apache 2. Then with the help of the run command, we are executing the commands one by one. So this is the CFG file. Now we need to go to the cloud init.tf, and we need to use that particular CFG file as a template. Now what I will do, I will go to the cloud init.tf, and inside the cloud init.tf, I will define the data. Then I will define a directive like template file. And over here, I need to provide the variable for this particular template file. So we can call it install Apache. Open the curly braces, close the curly braces. And here we need to mention the template equals file, double quotes, and define the file name. In my case, my file name is init.cfg. So I will call it init.cfg. Once the data template file be defined, you need to define another data template cloud init config, and I will name it like install apache underscore config. Put the configuration in the curly braces. I will choose the gunzip and base64 on, and after this we need to define some part over here, and inside the part we will define the part configuration, the file name, then the content type is cloud config, then we define the content is data, then the template file, then the template file name Apache install, and then I'm saying rendered. If you will define some other data, you need to define one more part over here. As we are defining only one data, so I'm defining only one part over here. Let's save this. Go to the create instance.tf, and inside the user data, we need to remove this. I will remove this, and I will call it data dot. Then inside the cloud init.tf, we have taken template cloud init config. I will copy this, provide it over here dot, then I need to provide the name of this variable, which is install hyphen apache hyphen config dot, then I need to provide the rendered as well, right? So right now I'm not reading the user data from the shell file, I'm reading the user data from this template config init config, which is the variable, right, which is this, and this particular data section is reading the part from this particular section. So this is the configuration if you want to pass the user data with the help of the cloud init file, right? I will do one more change over here. I will write the output of all these commands into a file. So I will define output all and write down the output into the where log cloud init hyphen output dot log file. Now let's save this and commit your code. Once the code commit will done, we will go to the machine where we are executing the Terraform. So you can see we are inside the machine. We will go to the directory Terraform and execute git pull. And we got all the files which we have created: cloud init, create instance, init.cfg, provider.tf, variable.tf. We will go to this directory Terraform for AWS. Then we have the user data. Let's put ls over here, right? We have the few files. We will generate the key. After generate the key, we will execute a command terraform init, and after this we will execute a command terraform plan. You can see two resources going to be added, right? If we will go to the create instance, then you can see inside the user data I'm getting the hash. Let's execute terraform apply. Provide your key, hit enter. Provide your confirmation, hit enter. Now you can see we are getting the public IP of our machine. I will copy this, clear out the console, and I will try to SSH. So in the command we will replace the IP. This is the command we are executing since last few lectures. So I hope right now you are much familiar with this. Hit enter, provide your confirmation. Let's go to the directory where log put ls, and here we are getting the cloud init.log. I will open this file. I will call cat cloud init.log because this is the file where we have stored all the logs. And if you will open this file, you can see this file is executing all the things which we have done inside the script. Let's clear out the console and execute systemctl status apache 2 and service is running. We have already copied the IP, the public IP of my machine. If I will go to the browser and I will paste the IP of my machine, which I copied from the terminal, you can see I'm getting the desired page deployed machine by Terraform. This is the file which we have written inside the index.html in Apache. So we have seen how we can pass the user data either with the help of the script or with the help of the cloud configuration. Sometimes you may have the question which part is better. It is better to pass the script with the help of the user data, or it is better to pass the script with the help of the cloud configuration. And my answer is both approach are equally important. But I generally prefer cloud init configuration instead of the user data as a script. So I hope right now you get the answer of many of your questions, that how we can execute something on the AWS instance after the launch of the instance. So we got the answer of these questions. We can execute the scripts with the help of the user data, and we can pass multiple scripts in the user data. There is no limitation as of now. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training, and today we will discuss about the another service in AWS called RDS. So we will discuss about the RDS application and what RDS stands for. So let's start with. So in Amazon, RDS is a Amazon Relational Database Service. Amazon provides the database as infrastructure as a service, which will allow user to create the database on the Amazon public cloud. So RDS is an Amazon managed DB solution which will help you to create the database service on the Amazon cloud, and Amazon cloud will maintain the complete database service from backup to upgrade. RDS manage the automatic backup, software patching, auto failure detection and the recovery. So as usual, whenever we are creating the services or the resources on the Amazon cloud, we don't need to manage about the infrastructure, right? We just need to manage the service. All the infrastructure management will be done by the Amazon. As whenever you will create the database on the Amazon database service RDS, Amazon will automatically manage the backup of your database. You can either configure your automatic backup or manual backup. You can also provide the retention policy with your backup, that for how many days you want to keep your backup. If there is any software patch or Amazon instance patch is required, that software patching will be done on the RDS without any downtime. Auto failure detection and the recovery. Whenever you will create the RDS service on the Amazon will recommend you to create the RDS service in the HA mode. HA mode means high availability mode. Whenever you are going to create the RDS service in the high availability mode, Amazon will spin up more than one instance for your database service, and both of these instances will be spin up in the different availability zone. Suppose you are going to create the Amazon RDS service in US East 2, then it may possible one instance will spin in US East A and another instance of the same RDS service will spin up in the US East 2C. When we are saying the high availability, it means the two instances will always be in the sync. It's Amazon responsibility to keep your database sync in both of the instances, although only one instance will serve the traffic. But in any case, if the first instance will be failed, the reason could be anything, that could be the server failure or that could be the availability zone failure, the second instance which is in the replication of the first instance will automatically serve the traffic, will automatically start serving the traffic. So it will help you to create the auto failure detection and recovery model. User have the automatic backup and the manual backup option in the Amazon RDS. If you want, you can configure the automatic backup, or if you want, you can configure the manual backup option as well. RDS supports the below RDBMS. Amazon RDS service supports a lot of database services like MySQL, MariaDB, PostgreSQL, Oracle SQL, and the Microsoft SQL Server. Whenever you will create the RDS service on Amazon, you will get the option which database service or which relational database management service you want to use. You can choose anyone listed on your screen. You can go with the MySQL, MariaDB, PostgreSQL, Oracle SQL, and the MySQL Server as per your application need. RDS have a HA functionality with auto replication. As I told you, you will get the option and the recommended option to create the RDS service in the high availability mode. High availability mode will basically spin up the parallel resources for your RDS service, and in case of the failure of one resource, the another resource will start serving the traffic. RDS or the relational database service also have the functionality of the auto scaling. So basically Amazon have a very good monitoring, and Amazon monitoring will continuously monitor your RDS service. And when the monitoring service will find that there is a need of the auto scale, RDS service will auto scale the storage capacity of your database without any downtime. The auto scaling in your RDS service will happen without any downtime. Service will not be interrupted on your RDS. If you want to create your RDS instance, then these are the steps to create the instance. First, you need to create the subnet group, which will allow which subnets the database will be in. So basically, as I told you that RDS service will be recommended in the HA mode. So you need to define the more than one subnet so that both of the instance will create in the different subnet. So that we need to create the subnet group, not only the single subnet. And this subnet will be the private subnet. Create parameter group. RDS service will allow you to create the parameters group, and with the help of these parameters your DB setting will be managed, because RDS will not allow the SSH connection, right? So that you can only manage the RDS service from the parameters. Create the security group. That is definitely an important point. For the incoming traffic and the outgoing traffic, you need to manage the security group. So you can create the security group in that way that only the instances which are executing your application will be able to access your RDS service. Create RDS instance itself. Once we will have the security group, parameter group, and the subnet group, we need to create the RDS instance. So these are the steps which we need to follow whenever we are going to create the RDS instance, and same step will be applicable whenever we will create the RDS from the Terraform. Here I'm listing few component of the AWS RDS. The first is the DB instances. Then we have the regions and the availability zone, which I told you. Then we have the security groups. We have the DB parameter groups, and we have the DB option groups. So these are the components which will be required whenever you will create the RDS service in Amazon. In the coming lecture, I will show you how we can create the RDS service with the help of the Terraform configuration file. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training, and today we will see how we can create the AWS RDS service with the help of the Terraform. In this lecture, we will create the VPC, we will create the RDS service, the subnet group, and the security group, and we will create an instance itself. After that, we will see how we can log into the RDS DB with the help of that particular instance. So let's go to the code editor and let's create the configuration file first. So I am here on my code editor. I will close all the files, and I will create one more directory inside my project called Terraform for AWS 2. Right over here, I have created the directory Terraform for AWS part 2. We will go to the first directory Terraform for AWS, and over here, if you remember, we have few common files like createinstance.tf, provider.tf, and variable.tf. I will copy all these three files and paste it in my Terraform for AWS 2. But before that, inside the Terraform for AWS Cloud 2, we will create one more directory called AWS RDS. And we will create these files createinstance.tf, provider.tf, and variable.tf in the AWS RDS. So over here we have copied the variable.tf, provider.tf, and the createinstance.tf. Let's do one thing. We have also created the VPC file inside the VPC net EC2 instance. I will copy that file as well, vpc.tf, and I will paste it here as well. So we have took these three files from the previous lectures. First, the create instance.tf. Here we have the key value pair, then we have the Amazon instance. Then we don't need the user data, so I will remove it. We need the key value pair. Let's leave the availability zone, the machine type, and the AMIs. We have the one output, public IP. Then the provider.aws is same. We are not going to change anything over here. Variables.tf have the same. The access key, the secret key, Amazon reason, US is 2. AMIs have the map, path to private key, path to public key, and the instance username. If you want, you can leave it as well, or you can remove it as well. Now, the vpc.tf, we have already discussed about it. In the vpc.tf, we have the AWS VPC level up, and this is my VPC name, level up VPC. Then we have the public subnets. Then we have the private subnets. Then we have some internet gateway as well. And then we have the routing table level up public. And after that, we have the routing table association with the public subnet. Now let's leave it as it is, and we will create one more file over here. That file will be called rds.tf. So in the theory lecture, we have discussed that we need few things to create the RDS, and very first thing was the subnet group. The subnet group is already here inside the VPC. We are creating the public and the private subnet, so we don't need to take care about the subnet. That will be created from the vpc.tf, which we have discussed in the earlier sections. The second one was the security groups. So we need to create the security group. If you remember, inside the vpc.net, we have created the security group as well. So if you want, you can keep the same file. So I will copy this file and I will paste that file as well. So we have copied the security group as well. Now we will do the change inside the security group as per my convenience. So right here we are defining the security group resource, then the name of the security group, allow level up SSH. Then we are defining the VPC ID, which is the level up VPC. Then we are defining the security group description. We are defining the egress and the ingress rule. And that security group we have used inside the instance. Let's copy this definition and paste it here. We will modify the comment and we will call it security group for the MariaDB. We are going to create the MariaDB service in AWS RDS, and we will name it allow MariaDB, right? Then the VPC ID will be same, aws.levelupvpc.id. We will change the name of the security group, which will be allow MariaDB. Then if you want, you can change the description as well. I'm going to change the description. Inside the egress, we will keep it same. From port 0, it means all port. To port 0, it means all port. The protocol -1, it means all protocol. And the CIDR block is for the all IPs. But we need to modify the ingress, right? Database is not accessible on port 22. SSH connection is accessible on TCP call port 22, but MariaDB database will be accessible on port 3306. So we will convert the port to 3306, and we will convert the two port as well to 3306. The protocol will be TCP, but this time for the CIDR block, instead of the CIDR block, we will define the security group inside the ingress. Right? So instead of the CIDR block, we will define the security groups. And inside the list, we will define the security group of the AWS instances which will be allowed to access the MariaDB. So as we are going to spin up the instance with this particular security group, so we will define this security group over here, right? So first we will define the resource, then the resource name, which is allow level up SSH, then define the ID. And I will remove the CIDR block over here. We will change the name as well, and instead of the label up SSH, I will keep it Maria. So what we are doing over here, so you can see in the earlier when we was defining the security group for the AWS instance, we was defining the security group ingress for the CIDR block of the IPs. But on the DB, we don't need the ingress from all of the instances. We need that few selective instance will be able to access my DB server. so that we are defining the ingress on the basis of the security group, that only the instance which have this particular security group will be access to this MariaDB, right, on which this particular security group will be attached. So we have defined the VPC, we have defined the security group, create instance is already here, and we need to associate the security group to the instance as well. So we will define the VPC security group IDs, and over here we need to define the security group, AWS security group dot your security group name. And what is the security group name? The name is allow level up SSH dot ID. So we have defined the security group, and we need to define the subnet as well. So we will define the subnet. We will go to the VPC. Over here we will go to the subnet, and let's define the public subnet one. So AWS subnet, define your public subnet first, use this subnet dot ID. So we have changed two things inside the instance. One is the VPC security IDs and another is the subnet. Now create one more file over here which is called rds.tf, and in this file we will define the RDS resources. So we have defined the VPC, we have defined the instance. Now we are going to define the RDS. So as per the requirement of the RDS, first we need to define the subnet groups. So we are defining a resource called AWS DB subnet group, and the subnet group name will be Maria-subnets, MariaDB-subnet. Then we are defining the same thing inside the name, and in the description I'm defining Amazon RDS subnet groups. Inside the subnet group IDs, you can see I'm defining the two IDs, AWS subnet level up VPC-private1.id and level up VPC private-2.id. If you will go to the VPC, you can see the private one is US East 2A and private 2 is US East 2B. The IP range we have 10.0.4, 10.0.5. So we have defined the subnet. After this, what we need to define? We need to define the security groups. Security group I have already defined over here inside the security group.tf, right? This is the security group for the MariaDB. What was the third thing? Third thing was the parameters. So we need to define the RDS parameters. So over here I'm defining the RDS parameters. I'm defining the resource AWS DB parameters group, and the name of the RDS parameters is level up MariaDB parameters. This is the same name which we are defining over here. I'm taking the MariaDB family 10.4, right? This is the MariaDB version. Currently, when I'm recording this video, 10.4.13 is the latest version available on the Amazon. When you are learning, either you can took 10.4 or you can took the latest one which you are getting in your AWS account. Then we are getting the description, and then we are getting the parameter max allowed packet, which is this. This is a random value. If you want, you can keep it. If you want, you can avoid it as well. Now, we have defined the subnet groups, we have defined the security group, we have defined the parameter group. What is the last option? Last option is the MariaDB instance itself. So I will define the RDS instance properties. And here is the complete configuration of the MariaDB resource. We are taking the resource AWS DB instance. The name of your resource will be level up MariaDB. I'm taking the allocated storage 20 GB, which will be the external size of your database. The engine, I'm taking the MariaDB. The engine version, it means the database version, we are going to take 10.4.8. The instance type, on which particular instance I want to access or spin up the MariaDB is db.t2.micro. If you want, you can choose the db.t2.small. The identifier and the name of the DB is the MariaDB. This is the username. This is the password, MariaDB141. You can take your own password. We are defining the DB subnet name. You can see the first thing we have defined the DB subnet, right? So I'm taking AWS DB subnet group and MariaDB subnet, so that it will take the private 1 and private 2 as a subnet. Then we are taking the parameter group name. Inside the parameter group name, we are defining this parameter group name which we have created over here, the AWS DB parameters group, then the variable name, then dot name. Then we are defining the multiple underscore AZ, which means multiple or multi availability. I'm taking it false. If you will keep it true, then this resource will create the two instance of your MariaDB, first in US East 2A and another one is the US East 2B. Then we are taking the security group associated with this DB instance. AWS security group, then the name of your security group which you have created for a MariaDB. So inside the security group, this is the security group which I created for the MariaDB, AWS allow hyphen MariaDB. So I'm taking the same over here. Then the storage type is GP2. The backup retention policy is 30 days. If you want, you can keep it anything. In which availability zone the instance will be created. I'm taking the availability zone as same, which is for the AWS subnet private 1. AWS subnet private 1 availability zone is US East 2A. So I'm taking the same availability zone. Skip final snapshot true, and then we are taking the some text with my DB. If you will go to the instance, inside the instance as well, we are taking the availability zone US East 2A. The key value pair, the VPC security group for the security group which we have created for the instance, and the subnet is public one. Let's save your code files and commit your code files. Before committing the code file, let's do one more thing. Let's output the endpoint of your MariaDB. So I'm taking the output RDS, value will be the AWS DB instance, then the name of your resource, then the endpoint. So this will display the endpoint of your MariaDB as the output. And if you will go to the create instance, over here we are displaying the public IP as the output. Let's save these files and commit these files. Once the commit will done, we will go to the machine where we are executing the Terraform. So here we are on the Terraform machine. We will go to the directory Terraform and execute git pull. You can see all files are basically downloaded, and we have created one more directory Terraform for AWS Cloud 2 AWS RDS. Let's go to this directory, right? Clear out the console, execute pwd, and we are inside the Terraform for AWS Cloud 2 and RDS. Puts ls. We have all the files over here: create instance.tf, provider.tf, rds.tf, security.tf, variable, and vpc.tf. Let's execute Terraform init. Initialization is done. Clear out the console. Create the security key. Security key is also being created. Execute Terraform plan. Provide the security key. And you can see 19 resources are going to be added in the AWS when I will execute the Terraform apply. If we will go through these resources, let's scroll to upside. So you can see it is going to create the MariaDB first, level up MariaDB. Inside the MariaDB, we are getting the allocated storage, the availability zone, the backup retention policies, the deletion automated backups, the engine version, the identifier, the name, and the multi availability zone. We are also getting the storage type and the username. Password is not displayed over here. Then the second resource will be created MariaDB parameters. We are getting the parameters over here, MariaDB parameter group. MariaDB, this is the family of the parameter. This is the name of the parameter. The parameters max allowed packet and the packet value. Then it is defining the MariaDB subnets. This is going to the subnet of the MariaDB. Then it is showing the my first instance, the security, the availability group, the password, machine type, the key name, security check. After that, the resources level up gateway. Then we have the level up key, level up public, level up routing table, the public routing table, level up public zone, and level up private zone SSH key. So these are the resources which will be created. Let's clear out the console and execute Terraform apply. Right? Provide your secret key, hit enter. Provide your confirmation, hit enter. It will start creating your resources. So whenever we are creating the MariaDB, we have to wait. It will take several minutes. So I'm going to pause this video and I will resume once all resources will be done. It may take up to 12 to 15 minutes. So we have to wait until all of the resources will be created. So over here we can see all the resources are being created, although only MariaDB took more than 7 minutes. Now we are getting the MariaDB endpoint as we have defined the endpoint in the public, and we are getting the public IP of my instance. Let's do one thing. Let's execute a command ssh, then the public IP, then -l Ubuntu, which is the username and the private key. Hit enter, put yes, and you can see we are inside the Amazon AWS instance. Let's do one thing. Let's execute sudo apt get update. Once done, we'll execute the command sudo apt get install, and we will install the MySQL client. Hit enter. For your confirmation, MySQL client is installed. Now we can connect with the MariaDB with the help of this MySQL client. So if you will execute a command MySQL -u, we have defined the root user as a user in the DB. Then -h, we need to define the host name. If you remember, we got the host name in the output variable. So we will copy this host name and we will provide in my command. Then we will provide -p and we need to define the password as well. What password we have defined for my DB? We have defined Maria 141. Hit enter, and there's a mistake. Although we are defining the all things correct, let's check the password. What was the password we have defined? So the password we have defined Maria DB141. Here we are defining Maria 141. Let's execute the command again and update the password. This is Maria DB141. Hit enter. Enter the password Maria DB141. Oh, there's a mistake. Between the password and your password there should be no gap. Hit enter, right? And you can see you are inside your DB. If you will execute so database, there should be databases, and see we are getting all 6 databases: information schema, InnoDB, MariaDB, MySQL, performance schema, and the test. These are the default database which will present in your MariaDB. Let's exit out. If you want to exit out from your AWS console, you can put exit. Now let's go to the browser, and on the browser we will go to the AWS. Over here let's go to the RDS. Over here we have DB instances, and one DB is running out of 40, and you can see MariaDB is running, right? CPU is 1.5% and zero connection, and currently active connection is 0. If we will create the connection again, we will go to the machine and we will create the database connection. Let's see, will it reflect on UI or not? Then after some wait, you can see we are getting one connection, right? So team, this is the way how we can create the DB instance in the RDS with the help of the Terraform. So these are the configuration files. Using the same way, it's a practice for you. Please try to create the DB instance for the MySQL. So now let's go back to the terminal and create Terraform destroy. Provide the security key, and once the processing will be done, provide the confirmation. Hit enter so that it will destroy all the resources which is being created in this lecture. It is a practice for you. Please try to create the RDS instance of MySQL or any other database so that you can get the more clarity. Rest, the VPC thing and the other things will be same. You just need to define your own parameters and your own DB definition. You will get the all required help from the AWS or the Terraform registry documentation. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training. And today we are going to discuss about the AWS IAM. In the AWS, IAM stands for the Access and Identity Management. We will see how we can manage the AWS public cloud security with the help of the IAM. So let's start with. In the AWS, IAM stands for the Access and Identity Management. As AWS is a public cloud, and if you are going to create your own infrastructure in the public cloud, then security is must, so that none other than your authorized person can access the resources of your cloud. Because if your AWS cloud access are public, then anybody or the unauthorized person can harm your infrastructure. They can potentially harm or even completely destroy your production services. So IAM is a very crucial part of the AWS, because on the public cloud, security is a very essential component. So let's discuss about the IAM and let's see how IAM help us to make the our infrastructure secure in the public clouds. IAM enable user to manage access to the AWS services and resources in the very secure manner. This is the basic application of the IAM. IAM enable the user to manage the AWS services. All the services which are present on the AWS cloud, the security of these services can be managed by the AWS. All the resources you are consuming on the AWS, the security of these resources can also be maintained by the IAM. AWS IAM is a web service for securely controlling access to the AWS resources. So as I told you, the complete access to the AWS resources can be managed by the IAM. Let's see how IAM work. So we are going to discuss how does the IAM works in AWS. So first component is the principal. Principal is an entity that can prefer action on the AWS resource, right? So any entity or anything that want to perform some action on the AWS resource, that could be the principal. That could be a user, that could be a role or an application itself. So if you remember, we are already working on the AWS, and to work with the AWS, we are providing the secret access key and secret access. With the help of the secret access, we are going to access the resource. So we are accessing the resource as a user. But in the last lecture, we have seen while we was accessing the MariaDB, we was using the AWS EC2 instance. We were not able to directly allow the connection on the MariaDB. We use the AWS instance, and AWS instance further make the connection on the MariaDB. So either a user or the application itself can be the principal. Second is the authentication. Authentication is the process of confirming the identity of the principal trying to access the AWS product. So whenever a principal is going to access or perform some actions on the AWS resource, first that principal need to authenticate with the AWS. First, that principal need to authenticate with the AWS IAM. The principal must provide its credential or required key for the authentication. Whenever we was logging to the AWS EC2 instances, we was providing the user and the private key as a credential, right? And whenever the AWS instance was trying to access the MariaDB, it was also providing the DB access, plus the security group of the AWS was whitelisted on the MariaDB. So authentication is required whenever a principal is trying to access or principal is trying to perform any actions on the AWS resources. Then third component is the request. A principal sent a request to AWS specify the action which resource should perform. So whenever any principal want to access or any principal want to perform any action on the AWS resource, principal will send the request. In that request, principal will specify the credentials, principal will specify the resource, and principal will also specify the type of action which is want to perform on the resource. Once the request will done, request need to be authorized, right? By default, all the resources are denied in the AWS. IAM authorize a request only if all part of the request are allowed by matching policy. Whenever we are sending the request, and as I told you, inside the request body you need to specify which resource you want to access, what kind of action you want to perform, and when that action will be performed, and who are you, right? So there could be the multiple components of the body. In the authorization, by default, all the resource actions are denied. IAM authorize a request only if all the parts of the body of the request are allowed by the matching policy. If matching policy on the resource is validating all the parts of the request, only and only then request will be successful. Otherwise, request will be denied. After authenticating and authorizing the request, AWS approve the action. So once the authentication and the authorization done, AWS approve the action which principal want to perform on the AWS resource. Next component of the IAM work is the actions. Actions are used to view, create, edit, or delete a resource in the AWS. And last component is the resource. Resource is something on which a set of actions need to be performed. Now let's discuss about the component of the IAM. What are the components of the IAM in AWS? First component of the IAM is the users. IAM user is an identity with an associated credential and the permission attached to it. So in the AWS, we have the users. Whenever we are creating the users, by default, we need to assign the credential to that user and the permission to that user. The user could be an actual person who is a user, or it could be an application that is a user. So for the AWS services, user could be the actual person who is trying to access the resource and performing some actions, or it could be an application as well. Suppose the web application want to create some DB on the DB services. So in that case, the web application is the user for the DB service. Each IAM user is associated with only one AWS account. You cannot create the users across the accounts in AWS. That is not allowed. IAM user scope is just limited to the one account. The next component of the IAM is the groups. Group is a collection of the IAM user. You can group multiple IAM users into a single group. IAM group used to specify the permission for the multiple users so that any permission applied to the group are applied to the individual users in that group. We can understand this thing with an example. And you want to provide the EC2 instances to all the developers. There could be the 100 to 1000 number of developers. So what you will do in that case? Will you go and assign the permission to each and individual developer? No. What we will do, we will create a group. In that group, we will keep all the developer users and we will provide the EC2 instance permission on that group so that the single permission will be applicable for all the users. In the same case, whenever you want to add some developer or whenever you want to remove some developer, you just need to add and remove the developer from that group, right? All the permission which you will allow on that group, these permission will be accessible by all the developers in that group. New member of the group inherit the policies and the permission of the group automatically, right? Whenever we will add the new member or we will remove the member from the group, we don't need to perform any action on that user, right? The new member which is going to add in the group, that will inherit the permission automatically, and the member which is going to remove from that group, the permission will be revoked from that user automatically. The third component of the IAM is policies. IAM policy is a set of permission and control access to the AWS resources. So we have the users, user can be grouped, and then we have the policy. So policy in the IAM is the set of the permission. Let's take an example. On the EC2 instance, you could have the multiple permissions. You could have the view permission, edit permission, delete permission, create permission. Same on the RDS, you could have the view permission, delete permission, edit permission, create permission. Same from the S3 bucket, you could have the view, edit, version, and n number of permissions. So whenever you want to club all the permissions, that club will create a policy. So in a policy, you can club or you can create a set of the permission, and that policy directly can be assigned to either the user or the group, so that all the members of that group or the user, whoever we are assigning the policy, that will have all the permission on the predefined set of resources. Policy is a JSON data document, and permission specify who has access to the resource and what actions they can perform. So permission is a JSON format document which will have the data that who can access the resource and what actions can be performed on that resource. Policy would contain the following information: who can access the resource, what actions the user can take on the resource, which AWS resource that user can access, and when they can be accessed. It means we have the defined time frame as well. With the policy, you can associate the policy expiration time as well, so that after a predefined time, that policy will be expired and the permission which is being provided by that policy will be revoked. And the last component of the IAM is the roles. IAM role is a set of permission that define what actions are allowed and denied by the entity in the AWS console. There's a minute difference between the roles and the policies. Roles will have the multiple policies, right? IAM role is a set of the permission that define actions, that which actions are allowed by an entity on the AWS console. Roles permission are temporary credentials. So we can take an example. Suppose we have the database service and we have the EC2 instances running the web application. Whenever we want that only the backend node of my web application can access the database, so we can assign the role to the backend instance only. We will not assign that role to the front end instance, so that only the backend instance can access and modify the database in my DB service. So that is about the IAM inside the AWS. In the coming two lectures, we will see a lab on the IAM. So thank you, team. See you in the next lecture. Hello, team. Welcome back. Welcome to Terraform training. And today we will see a lab on how we can create IAM users and the groups in AWS. So let's go to the code editor and let's see how we can create the configuration file for the IAM users and the IAM groups. So here we are on the code editor. I will close all the currently open files. And over here inside the Terraform for AWS 2, I will create one more directory called AWS IAM. So we have created one more folder called AWS IAM. I will go to the AWS RDS and copy few files from AWS RDS to AWS IAM. I will copy the variables.tf, provider.tf, and the create instance.tf. I will paste these files inside the AWS IAM. Now I have the create instance.tf, provider.tf and the variable.tf inside the AWS IAM. Let's remove the create instance.tf as well. I don't need this create instance.tf right now. I will only need provider.tf and variables.tf. Now let's do one thing. From the AWS RDS, let's copy the provider.tf and paste it inside the AWS IAM. So we have pasted the provider.tf which have the AWS provider access. Now over here I will create one more file and I will call it IAM user.tf. Here what we will do, here we will create the IAM users. So we mentioned the command tf file for the IAM users and the groups. To create the user, you need to define the resource like AWS IAM user, then the variable name of that resource and the name of your IAM user. This will create the IAM user named admin user1. Let's copy this and paste it one more time. And suppose we are creating IAM admin user2 as well. Now we have created the users. Let's create the group of these users. So we will define the group definition. So I have defined the group over here, AWS IAM group. The variable name of this resource will be admin group and the group name will be admin group. How we can assign these users to this particular group? And that assignment can be done by resource AWS IAM group membership. Right? We are defining a resource AWS group membership. The name of the resource will be admin-users. I'm taking the same name over here. Then I'm defining the list of the users, which users I want to keep in this AWS group membership. So I'm taking AWS IAM user, admin user 1 dot name, AWS IAM user, admin user 2 dot name, and in which group I want to assign these users. I want to assign these users in a AWS IAM group, admin group dot name. So we have defined the group, we have defined the users, we have defined the association of the group and the user, but still the policy is pending. We need to define the policy which will be applied on this particular group so that the users will have the same policy. Let's define the policy for the group. And here I'm defining the policy for the group. AWS IAM policy attachment, defining the variable name admin user attach, defining the name of this particular resource admin user attach, defining the group, the list of the group on which this policy will be applied, which is AWS IAM group admin group dot name, and then defining the policy ARN. Policy ARN is ARN AWS IAM AWS policy administrator access. It means I'm defining the administrator access on this particular group, and all the users which is the part of this group will also have the administrator access. Let's save this. Team, please make sure whenever we are providing the administrator access with the help of the Terraform, then after this lecture, we are not going to use the Terraform destroy. If we are going to execute the Terraform destroy, that may impact your account. So please make sure if we are providing the administrator access, then we are not going to execute the Terraform destroy. Otherwise, it will destroy this particular group and it may also impact your account. I have seen few examples where I was using the Terraform and administrator access and executed a Terraform destroy. Then I faced some problem in my AWS account. So this is a warning for you. Please don't execute Terraform destroy after this lecture or from this particular directory after creating these users. Or you can take some other policy over here. You can go to the Amazon. There is a list of the policies. You can take any policy, and these are the logical entities. So if you are creating the logical entities, Amazon will not charge on your free account. We will not execute the Terraform destroy after this lecture, right? Or after the creation of these resources. So we have created the muser.tf provider.tf. Let's create the variable.tf as well, because variable.tf have my user key. So here I have the access key. Let's leave the other things as it is. I'm not going to touch these things. What I will do, I will save the files and commit this code. Once the code commit will done, we will go to the machine where we are executing the Terraform. So we are inside the Terraform machine. We will go to the directory Terraform and execute git pull. You can see all three files are basically created on my machine. I will go to the folder Terraform, AWS Cloud 2, and instead of the AWS RDS, I will go to the AWS IAM. Put ls, and we have the IAM user.tf, provider.tf, and variable.tf. Let's execute Terraform init. Clear out the console and execute Terraform plan. Terraform plan is going to add 5 resources, 2 users, 1 security group, 1 policy, and one association. Let's execute Terraform apply. Once it will ask provide your confirmation, and all done, right? It has created the admin user 1, admin user 2, administrator group, then created the membership, then created the attachment, right? And membership is completed. So these 5 resources is being created, which is the AM admin group and the users. If you want, you can confirm on the AWS as well. So you can go to the IAM in your account. You can see we have the 3 users, 2 groups, 3 roles, right? We have not created the roles, we have created the users and the groups only. If we will go to the users, then you can see we have the admin user 1 and admin user 2. If we will go to the groups, we have the Terraform admin group and admin group. This is the new group which we have created. Let's open this. This have the 2 users, admin user 1 and admin user 2. Inside the permissions, you can see it has the administration access, right, which we have attached. Access advisor, there's a lot of permissions you can attach to this group. Right now I'm not going to attach that particular thing. So this is the way how you can create the users and the groups with the help of the Terraform in AWS. So thank you team, see you in the next lecture.